as here there is no light, nothing when the mains power is applied. We assume that it's the power supply that is faulty, and we have to remove it and look at it more closely. But here's how you do it. First, there are two reddish screws here and here that you have to remove. Then three black screws at the back here. They're black like this. And that is not it, because you will see that the power supply is loose, but there is something that is holding it inside, and that's the ribbon cable which supplies the power to the other bits of the VCR. So you have to remove four more reddish screws on this large PCB. One of them is a special one, pay attention to that. And you have to remove four kinda yellow Layton style screws which are close to the edge here, four as well, and two more black ones on the back there. And that's when you can finally lift this edge of the PCB. And once you do it from behind, you unhook the ribbon cable which is there, and it gives you more leeway to remove the ribbon cable together with the whole PCB assembly. So don't try to pull on it when you remove the first 5 screws, the 2 reddish ones and the 3 at the back, because that's not enough. You have to get access to that hook and lift off this slant, this large PCB first, and that's how you remove the power supply unit. Once the power supply unit is out of the VCR and on the workbench, I shall proceed to remove this lead and other things that prevent us from accessing the soldering pads of the components, and so that we can check those components for faulty electrolytic capacitors. Like this plastic cover should be removed as well. It protects the floating primary on this power supply unit. So now the connections and the soldering pads are exposed, and the first thing to do in this case now is to discharge or make sure that the reservoir capacitor which holds the rectifying mains voltage is discharged, because safety first, better safe than sorry. And for this it's very easy to do. You just take a light bulb with a few 2 wires attached to that, and then you, via this light bulb, you short the capacitor for it to discharge. This time, as you can see, there was no voltage on this large capacitor, but sometimes that will be the case, and you have always to do this just to stay safe. And you will use a NEOSR meter, like ones you can buy online for about $35 US, or you can use a homebrew one like this one that I've built, and then you proceed to check all the capacitors by identifying and making notes of those capacitors they have tested with the high ESR for later removal. After having determined which electrolytic capacitors were bad with an ESR meter, I will be proceeding to remove them, all of them, one by one, including those that test somewhat in between good and bad, because they are, for a critical application like switch mode power supply, they are no longer of any use. They could be probably reused in some lesser applications, but not in a switch mode power supply. So to start with, even if it seems a little bit counterintuitive, I would add some new solder to the old solder joints, just to freshen up, because the solder connection, they have become a little bit oxidized, there is a little bit grime and dirt maybe on them, even if you don't see it. So first of all, to add some new solder to the old solder joint, like this. And even if it's looks like there is excess solder, this will be removed later on, like this. To remove the solder from the old component, I will use a solder braid like this one. This, like any regular one would do. You can buy branded, but in my experience they all work very well. And using a bit of this desoldering braid, I will remove the faulty capacitor. Okay. I will clip off the bits that have been already used up and soaked in solder, and I will apply the same procedure for the other lead, trying to make sure I don't touch any of the adjacent components, and I'm trying to mop up the solder basically. Yes. Oftentimes when these units were assembled, there was a way of mounting the capacitors by bending their leads, which is not very good for the time when you have to desolder them. And for that reason, sometimes you have to, after you have mopped up the solder and it looks like there is nothing left, you have still to, because the component lead or the remnants of it are flush on a soldering pad, you have to add an extra step in the desoldering process. You have to, let's finish this first. Yeah, so these leads, they might look like they are already free, but probably because they are flush on the soldering pad, there is still some solder connection remaining, and you have to use a tool maybe like this one, or something like a knife, and you put gentle pressure on the lead itself, and you try to hit only the lead, not the solder pad, until you feel that it's moving away freely. And if this happens on its own without any extra work, then so the better. Once it is unsoldered, you remove the component, which looks actually like it has been leaking a little bit, and that's it. Basically, one by one you remove all the components that tested bad on the ESR meter, or even in between good and bad. Still, it's better to remove them and replace them with new units. Once all the bad capacitors have been removed, it's time to put new good ones in their place, and there is nothing much to it really. It's basic soldering. Just please don't forget to observe polarity, as these are polarized devices and are known to explode in a spectacular fashion when inserted the wrong way around. I think it will suffice for me to show one instance of a capacitor being soldered into place. The last one I have to replace. This one is on the primary side, and quite tricky to slide it in its position on the PCB, but I managed. Now same story, I make a little donut of solder with the pliers. I cut it off. Now holding the capacitor in place with one hand, I put the donut on one of the leads. It stays put because it's a donut. It cannot go away. Just soldering the lead like this. As you can see, now that one lead is in place, I can hold the soldering iron in one hand and the soldering dispenser in the other, and here it's already easier. You just hit the component lead and the pad, and very quickly you have a nice soldering connection. And that's all the capacitors replaced now. Now that all the soldering has been done, and I've cleaned up the board with some alcohol from rosin residue, I will proceed to reassemble the power supply and to connect it for a first test to find out whether the replacement of all the faulty capacitors has solved the problem, and the power supply will now start up normally. That's now that all the notes that you've taken, like these ones I have here, they come handy because I know which side to put back everything. That's it. Everything now assembled, and the unit is ready for a first test. So now, after having done the recapping, I will put this unit on test and we'll see if this has cured the patient or some more work is required. So let's start by applying some power. Oh, it beeps and there is light, so let's try this. Okay, play. Oh, the head spins, so, and the tape runs, so I would say it is a success. But it is not always as easy as this. Sometimes, besides the capacitors, you have to also check semiconductors, especially diodes. Sometimes these diodes fail in a way that when you test them with the multimeter they seem okay, but under load they fail, so you have to check them one by one. But this one was easy and nice. And thanks for watching. If you like it, then give me a thumbs up, and if you'd like to see more video like this, then leave it in the comments below. Cheers, bye bye.